So we've been looking at the fundamental theorem of calculus. And there are some things that we want to remind ourselves of before we go after the question that we left off with on Friday. So when we're looking at the definite integral from a to b of f of x dx and saying with the fundamental theorem of calculus that this is capital F at b minus capital F at a, where capital F is an antiderivative of f, what we're saying is that capital F prime is little f. So we're integrating capital F prime, which is the rate of change of capital F. We're integrating the rate of change. And what this tells us is how much the function changed on the interval. So that's the change, the integral of capital F prime dx is the change in f on that interval. The amount of change in f on the interval from a to b. So it's the amount of change. So if we integrate a rate of change of a function, we learn how much the function changed on that interval. That's what f at b minus f at a is. It's where we ended up, f of b. It's the difference, it's the difference between where we ended up, f at b, and where we started, capital F at a. So sometimes we summarize this by saying the definite integral of a rate of change gives the change in the function. Or sometimes I say the amount of change in the function. Sometimes I say the total change in the function, which is wording that I'm not too fond of, but it was inflicted upon me when I was learning calculus, and habits are hard to break. So the definite integral of a rate of change gives the total change in the function. See, I just did it again. But that's how we read capital F at b minus capital F at a. That's how much the function f changed from a to b, where we started and where we ended up. The difference between where we started and where we ended up. All right. So we've been framing this as the area under the curve of f of x and above the interval from a to b. So the question that we had last time, what if the function is negative on the interval from a to b? That was the question that we left off with last time. What if f of x is negative on the interval from a to b? So let's do an example of that and see what happens. So let's come up with a function that is going to be negative on an interval. So for example, let's say we want to integrate from 0 to 2 the function x squared minus 4 dx. So what we're looking at we got a parabola. There's the function x squared minus 4. It has x-intercepts at -2 and 2, but I'm only concerned with what's going on between 0 and 2. So let's see what the antiderivative, or let's see what the definite integral from 0 to 2 of x squared minus 4, a function that is negative on the interval from a to b. Let's see what this tells us. So we need to find the antiderivative of x squared minus 4. So that's going to be a 1/3 x cubed minus 4x. And then we'll evaluate from 0 to 2. Plug in 2, plug in 0, subtract. So 1/3 x cubed minus 4x is the antiderivative of the function x squared minus 4. So x squared minus 4 is the rate of change of 1/3 x cubed minus 4x. Let's see how much the antiderivative 1/3 x cubed minus 4x changes between 0 and 2. So first we'll plug in 2, so we get a 1/3 2 cubed minus 4 2's. And then a 1/3 0 cubed minus 4 zeros. So we get 8 cubed minus 8. So 8 cubed minus 24 is negative 16 cubed. Or sorry, negative 16 thirds. I think at one point I said 8 cubed and I meant 8 thirds. So we got 8 thirds minus 8. Low on space. And 8 is 24 thirds. And 8 minus 24 is negative 16. So when our function was negative on the interval from a to b, the definite integral came back with a negative value. Let's talk about why this makes sense. The rate of change is negative, so our function is decreasing. This is how much the function decreased. The rate of change is negative, so our function decreased. The definite integral tells us how much the function decreased. X squared minus 4 is the rate of change. And the rate of change is negative. So the function is decreasing. Rate of change is negative, therefore function is decreasing. And the definite integral indicates how much the function decreased. So everything fits together nicely. If the rate of change is negative, then the function is decreasing. The definite integral tells you how much the function decreased. The 3 dots is a therefore. Rate of change is negative, therefore capital F is decreasing, and the definite integral is how much the function decreased. Any questions? Let's look at another example where a function is sometimes decreasing and sometimes increasing. So let's look at a definite integral where sometimes the function we're integrating is negative and sometimes the function we're integrating is positive. So let's look at another example. Let's integrate from -1 to 2 the function x plus 1 times x minus 2 dx. Take a look at what this function looks like. So we're going to integrate this function from -1 to 2. Here's what the function looks like. We can see sometimes this function is above the x-axis, and sometimes the function is below the x-axis. So sometimes above, sometimes below. So if we graph it, we'll see that sometimes, so this is going to be we're integrating this function. We're integrating this function, so this is the rate of change of some antiderivative. And we can see that the derivative between between -1 and 0, the rate of change is positive, so we should see a function that's increasing. But then from 0 to 2, we see that the rate of derivative, the rate of change, is negative, so we should see a function that is decreasing. So if I call this little f, we see on the interval from -1 to 0, f of x is less than 0. F of x is negative. That is, f prime of x is negative. Therefore, f is it's positive. Yeesh, I had it backwards. Therefore, f is increasing. So if we integrate from -1 to 0, we should get a positive amount. The antiderivative will be increasing. On the interval from 0 to 2, these should be open intervals. Our f of x is negative. That is, the derivative is negative. Therefore, capital F is decreasing. So on the interval from -1 to 2, sometimes the function is increasing and sometimes the function is decreasing. That was starting to bug me. So capital F is increasing. And then from -1 to 0, and then decreasing from 0 to 2. And the area will tell us by how much. Let's integrate from -1 to 2. See, the green integral will be from, -1 to 0 of x plus 1 times x minus 2 to x. And rather than integrating this function, we have it on our calculating machine. So let's just second calculate an integral from -1 to 0. And we get 0.417. If we quit and go math 9, integrate y1 with respect to x from -1 to 0, we get the 0.416. We get a positive value, and if we want a fraction, let's see if we can make a fraction, 5/12. So between -1 and 0, the antiderivative increases by 5/12. The derivative is positive, so the function is increasing. The definite integral tells us how much. Let's look at this negative integral. If we go from 0 to 2, the same function, if I go back and integrate the same function, this time from 0 to 2, and make it a fraction, I get -8/3. Which is about -2 2/3. That makes sense. We see more area between 0 and 2. This looks like a bigger area. So the amount of decrease is more than the amount of increase from -1 to 0. And that's evident in our graph. We see the amount of increase there that is highlighted. And then if we calculate the amount of decrease from 0 to 2, we get the negative 2.667 from 0 to 2. So things are aligning with what we understand about derivatives. Now, if we integrate all the way from negative 1 to 2, if we calculate the integral from negative 1 to 2, that'll shade in the two things we've already shaded, we get a negative 2.25. If we do this using the commands on the front of the calculator from the home screen, oops, and change this to a negative 1 to 2, we get the negative 2.25, which is a fraction, is negative 9/4. The other thing that we find out is that if we take the 5/12s, that's the amount the function increased from negative 1 to 2, the antiderivative. We take 5/12s and we subtract the 8/3, we end up with a negative 9/4. Easier to see in the decimals. 2,667 minus the 0.417, 6 minus 4 is 2, 6 minus 1 is 5, 7 minus 7 is 0. So that works out. Here's the amount the antiderivative increased. Here's the amount it decreased. Here's the total change from negative 1 to 2. So 5/12 is the area. That's indicating the amount of increase from negative 1 to 0. Negative 8/3. Negative 8/3 is the amount of decrease from 0 to 2. And if we add those up, that tells us the total amount of change from negative 1 to 2. Any questions? Comments? Deep thought or snide remarks? All right, let's pause the video here and talk about what's coming next.